taking on the change of base formula. The reason why this comes to be has to do with the fact that all of the calculators that we come across, for the most part, usually have to deal with base E or base 10. So that allows us to punch logarithms in directly as long as their base is E or 10. Later on, when we get into solving log equations, we learn how this change of base formula came to be. So stay tuned for that, but I thought I'd give it to you a little bit earlier so that you can use it if you need it. So what this change of base formula does for us, super powerful, it allows us to rewrite any logarithm with any base with whatever base we would like. So, you know, our most popular bases again, base E, base 10. So what I'm trying to say, if you see log base A of X, that's what we're looking at, any logarithm. If you're into looking at base E, that is usually the natural log. So you can rewrite it so that you have the natural log of X. So that's the natural log of the argument over the natural log of the original base. So in both cases, those bases are E, and we can directly type them into our calculators. Same story. If you are looking at base 10, that's another popular one on your calculator. If you would like to rewrite any log in terms of base 10, you can rewrite it so it's log of X. So remember, when there is no base written, it's assumed that it's a 10. That's the log of the argument over the log of the original base. So in both cases, we have that base of 10 so that you can see that. So I'm going to approach to do this. Sometimes we care to do this if we want to see the graph of a logarithm without having to convert to exponential form and pick a lot of X values and Y values. This might be a little nicer way to take advantage of this. Looking at example 4, if it's asking us to graph the following function, I see that it has a logarithm in it. So I do see some shifting going on, a horizontal shift and a vertical shift, but what I want to focus on is just looking at the fact that there's a logarithm in this function and it's got a base 2. Now, depending on what type of calculator you have, if it can't handle a base 2, the next thing we would do is just rewrite it. So remember, f of x is still f of x. The 4 is 4, nothing has changed there. But if you want to convert this log expression into something that's a little more user-friendly, maybe something with a base 10, you can rewrite it so that it's a fraction. So I'll show you that. And what we're looking at is it's always the log of the argument. So in our case, the argument is x plus 3 over log of the original base. So in our case, the base was 2. Now, if I'm just using log, that's assuming that my base is 10. If you feel that you want to write that in there, that's okay. So this is another way to write this particular function. We could type this into our TI and we will get the graph. And I'll do that for you. So let's pull up our TI. I have something from my old example. But let's go and we'll erase everything out. And we'll type in the 4 plus, now remember this is a fraction. What I like to do is I'm a little bit cautious whenever I have a fraction that has more than one term in it. So I'm going to enclose the entire numerator, the log of x plus 3, log key, right beneath the square key, x plus 3. So that's the argument. Close the argument with a parenthesis, close the numerator with a parenthesis. That is divided by, and this is only a single log in the denominator. If you prefer, you could also be cautious and enclose that log. That's log, and we have a 2 in that argument. So if I'm only using log, I'm assuming it's base 10, I'll close that denominator. So now if I enter that and I press graph, you see that we have the logarithm. And you may, I mean, sometimes it looks a little bit suspicious. Log graphs don't exactly look like this. So let me kind of pull this off to the side for you. I'll take a copy of it, bring it back to our drawing board, kind of show you. Paste this. We'll grow it up a little bit. There we go. Kind of keep in mind what's going on. It's a logarithm is really just an exponential function. It's the inverse of an exponential function. So right now it looks a little suspicious, the fact that we've got something kind of stopping. Technically what's happening is we've got ourselves a vertical asymptote at -3 VA. And what happens is the function, limitations of technology here, is technically hugging that vertical asymptote, getting closer and closer and closer to it, although I don't have a steady hand with that vertical asymptote. But it's getting closer and closer and closer to it until it actually doesn't touch it. It just gets really super close. That's all I have to say there. So that is our log function. Another way to look at that. So that's a very nice graph. They didn't really ask us much to do after that, but that's just how we get that on the paper. What I also would probably explore, you know, we could always go back to, if we didn't want to use base 10, what if we rewrote it using the natural log? So what if we have the natural log of x plus 3 over the natural log of 2? And I guess you wouldn't need parentheses there. That's assuming you're rewriting it with base e. The question would be, do we get the same graph? And according to the change of base formula, we should. But if I were you, ask why. Does it really work? Let's go back and check. So let's go back to our TI. We will rewrite that in the function editor. So go to the y equals. I'll erase it out for now. I have 4 plus, if I want to do natural log of the argument, I'm enclosing the natural log in parentheses. So ln, that's beneath the log button, log, right by the number 4. X plus 3. Close that argument off, close that numerator off. It's divided by natural log of 2. And if you want to, be a little bit more cautious. Kind of nice, natural log of 2 is just a single constant, but just in case, I'll enclose that also in. Give me a second, I think I double clicked that. There we go. Got a little fast response there. But I have the natural log of 2, closing the argument, closing the denominator. So we enter this and we graph it. It looks like we have the same graph. Let's copy it over and see. Can compare it. So let's go back to our new graph. There's my copy, but let me go back to our picture and just see if we can explore this a little bit. Paste this for ourselves and look at what we have here. It is exactly the same graph. Pretty cool, huh? So moral of the story is, you know, is it better to use base 10? Is it better to use base E? Totally up to you. When you graph, it's whatever's easier, as long as you are being consistent. You're using, in both cases, the log has to be the same base for the numerator and denominator. And always make sure it's the log of the argument on top. I'll emphasize that. Log of the argument and a log of the base on the bottom. That kind of helps us remember what to do. So that change of base formula comes in handy, especially if you have an older operating system. But I'm going to show you one more trick that sometimes you can totally avoid the change of base if you'd like. If your calculator has a newer operating system and be a TI, it actually has log tables incorporated into it no matter what the base is. So if you'd like to deal with that, let's go and find that for ourselves. Let's try this one more time. Let me go back to our TI. and how we type this in. I know it's a 4, no problem. But remember, it was log base 2 of x plus 3. Now, the newer operating systems of the TI, if you press math, you can press number. What we can do is look for it, scroll down, the arrow key. If I remember correctly where it was, I guess I lied, it's under math. My fault. There it is. See, sometimes like when I don't know where it's at, it's either under the math key or the number menu, so at least we're okay. But let's check it out. If you scroll down, so let's go back real quick. I got 4 plus, and my job is to find the log base key. If I go to math, and I scroll down all the way, I believe it's item number A, it's something called log base. Now in a TI-84 CE or C, if you press enter, it automatically gives you the log and you have a box to fill in the base and a box to fill in the argument. So we can right away fill in item base 2 and we have an x plus 3 in the argument. Your other calculator, if you have like a little older version of a TI-84 or maybe a TI-83, log base key works, but you have to kind of look up the syntax. So like the question would be, should I press the base first, comma, and then the argument, or the argument first and then the base? I encourage you, just Google it. Go look it up and see what you press, and you'll be able to use the same thing. Or just go back to the change of base formula, whatever suits you. But I just wanted to show you that yes, you can enter this in newer operating systems. If we press enter, we graph it, you will see right away, same exact graph. If you're not sure and you don't believe me, we can copy it over just in case. And you will see if I have the side-by-side pictures. Copy it over here so you see it. Paste it. And yes, we've got our same exact graph that we've been playing with. So that's super nice. And one more time, if you're interested, so just in case, if you have a newer operating system, you can press the math key. Then you're still on the math menu. If you press or A or go down to item A, you'd be dealing with the log base key. So that's another way to approach this. If you want to evaluate logs right away, feel free. Whatever operating system you have, just know how to use it, and you'll be fine either way. So I hope this helps. We'll see you in the next example.